Honors Algebra 2, Chapter 6, Section 5. We're looking at graphing roots, square roots, cube roots. Let's first review though. So if we're gonna graph x squared here, we should recall that we have the vertex is going to be 0, 0, and then we have 1, 1, 2, 4. I'm just plotting points. Again, you just plug them in if you don't know the pattern. So here's the parabola we get for that graph. We do it again down here. We're x cubed. 0, 0 is the point of inflection. We had 1, 1, 2, 8. And then we had a negative 1, negative 1, and then negative 2, negative 8. And we had this shape. And so these are two shapes we talked about previously with polynomials, these quadratics and the cube functions. For here, our goal today is to graph roots. And so we're going to graph square roots and cube roots are the two major functions we're going to graph. So we're graphing a square root. Now we can make a table just to help us graph it. So we choose some values. Let's choose negative 4, 0, 1, 4. And I skipped 2 and 3 for a reason, because we're going to plug them in here, and so it's going to be the square root of our x value. So the square root of negative 4 is 2i. And so we're not going to be plotting that. I just want to give you an example that the negative here, we don't really want to plot the imaginary solution. And so 0 would be 0, 1 is 1, 4, square root of 4 is 2. The next one I would have is going to, for the x value, would be 9, and that would give us a y value of 3. So I plot that. We had 0, 0, 1, 1, 4, 2, 9, 3, and so we have this shaped graph. And for this function, it does not continue left at all, and it actually stops. There's not an arrow here. If we look at our inverse functions we've already talked about from last section, we look at y equals x squared. It had an inverse function of the inverse of f would be the square root of x. And so when really it would be the plus or minus, and so that gave us the entire sideways parabola, which we mentioned how this is not a function. So what we do is we restrict it so we only have that top part. And so our domain here are going to be all values of x. If we look at our graph, what x values work here are all values of x that are greater than or equal to 0. Or I could say positive real numbers. The range of the y values are all y values that are greater than or equal to 0. So these are what makes sense for the graph. What values will you find a solution for? Now the cube root for here, if we make another chart, and we plug in negative values, let's do a negative 8. So the cube root of negative 8 is negative 2. And that's because negative 2 times a negative 2 times a negative 2 is still negative 8. So our negative cube roots, those odd number roots, can have a negative underneath the radical sign. The next smallest, or the next bigger value of x I want to use would be negative 1. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So these are the values I would choose. So we have 0, 0, 1, 1, 8, 2. And we have the same values of negative 1, negative 1, negative 8, negative 2. So we have this shape. Which this should look familiar to you because cube roots are the inverses of cubic functions. So if you kind of rotate over that y equals x line again, it lays flat to give you this shape. For this one, our domain is all real numbers and our range is all real numbers, all positive and negative real numbers going up and down forever, left and right forever. So these are two major functions we're going to talk about. All we're going to do to our graphs is look at how some of these values affect it. What does this number in front here do to our graph? And so we should recall from our previous sections that that number multiplied to the x is called a. And so we've seen it before. We've seen it in like y equals a times the absolute value of x minus h plus k. We've seen it in y equals a times the quantity of x minus h squared plus k. We're going to see that again in this section. We're going to have a in front here. And a still will, the a value still makes the graph open up or down. So it's a reflection, and it's a vertical stretch. So when the value, I should say stretch or shrink. So we have a graph. Here we have that square root graph. The a value will take that and make it stretch it up, or it will shrink it down. And so the a value will shrink or stretch the graph vertically. It also will reflect the graph. So if the a is negative, then instead of going upwards, it'll go downward. And so that's what the a tells us. H is the number in front, is a number being added or subtracted to x. H is still the opposite of what you see. H is a horizontal shift. It moves our starting value, like our vertex or point of inflection, so our starting value here or here, it moves that horizontally left or right. And then K is a vertical shift. And so that number outside the radical. And be careful because K is outside the radical, so we really need to make sure we know if it's underneath the radical sign or outside the radical. If it's applying to x, it's underneath it. If it's outside, it's actually applying to our y value. So that's kind of a quick review. So the overall form we're going to look at here for roots is going to be y equals sum in root, and it's going to have a in the front. So a times the nth root of x minus h, then plus k on the outside. So a, h, and k are the same that we've talked about in the past, just with the radical signs. So how would we get this function, or we start with this function? What would you do to the graph to get this equation? So you take the original equation here. What's happening? Well, we are shifting it. We're going to move it right 3, and then we're going to move it up 2. And that's just using our h value and our k value. Well, how are we moving it? So for this one, we have a negative value. So we could say it's a vertical reflection. And then the plus 12 means we move it left 12. So knowing how these numbers change the parent function or original function. So we can graph these without a calculator so that we can apply the shift first. So we go to right 3 and up 2. Then it's also going to be a reflection. Now the parent function is the square root of x. So we apply all of our table we did for our square root of x to the new point, and we apply the reflection. So instead of having the upwards, it's going to go downward. That's the general shape. So knowing the shape of the square root function, and then applying the table here, if I go right 1, I'm going to go down 1. And that's also applying that awesome a value we talked about. That still works here. Our a value is -1. So if I go right 1, I'm going down 1 to find that red point. If I go right 1, 2, 3, 4, I'm going to go down 2. And that's because the square root of 4 I know is 2. And that's that movement we learned from that first graph. So here's the shape of the graph, that curve, the square root. It stops at the purple and then has an arrow downward to the right. The domain here is from that purple point to the right. So from an x value of 3 right. So x has to be greater than or equal to 3. Our range is from that purple point down. So from that k value, so y has to be less than or equal to 2. And that's using these values to help us find those 2 points of the domain range. For the next one here, we have a shift of left 1 and then down 3. Our a value is 1, and we have that, here's that general shape for the cube root function. So I'm going to go right 1, up 1, left 1, down 1. From this original point we plotted, I'll do it in red so you can see which one I'm talking about here. So from this red point, that's that starting base value here, I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8, and then I can go up 1, 2. So that's again the cube root of 8. We go left 8, 1, 2, 3, 4, 5, 6, 7, 8. I can go down 2 to get that point. If you don't like moving off of this point, finding points from that point of inflection, you could still make a table. And when you make the table, you ever think of like the cube root of some number plus 1 minus 3. So what do you know the cube root of? We know the cube root of 8, so x needs to be 7. So then you would get the cube root of 8 is 2, and 2 minus 3 is negative 1. So you can do it that way as well if you wanted to find that 7, negative 1 point right here. So we can connect these, or try to connect these. That didn't work out. Let's try to connect these here. And some arrows on it. So our domain here goes all real numbers because we're going left and right forever, and we're also going up and down forever. Not very fast, but we are. And so it comes back to our parent functions where we know what the square root and cube root are, and then we're just moving them and reflecting them. So another one here, let's look at, let me do this one for you. I'm going to do the second one. I'm going to have you do the first one for a homework problem. So I'm going to shift it right 2, up 3, and then I can use the power of a. Let me first to my cube root function. So here's a cube root graph, but because my a value is negative, I'm going to go the other way. I'm going to go downward. So this is the shape I'm going to look for in my graph. That's what it needs to be. Now, the awesome a value says from this point of inflection, the hk value, I'm going to go right 1, I'm going to go down negative 5 halves, which is negative 2 1/2. Then I'm going to go left 1, I'm going to go up 2 1/2. Now that a value is actually stretching our graph, so that theory about moving right 8 up or down 2, we got to be careful with that because we have an a value. So this a value, let's see what happens when we're doing the cube root of some number minus 2 plus 3. So again, we know the cube root of 8. So to get that cube root of 8, we need x to be 10. So then we have the cube root of 10 minus 2, we get the cube root of 8. So the cube root of 8 is really 2. So then I can actually solve this. I get negative 5 plus 3, which is negative 2. So if we go down here to 10, we're down here at negative 2. So notice how if I go right from the blue point 8, I'm at 10, but I'm not going to go down 2, I'm actually going down further than that because the negative 5 halves stretches that graph. If I go, we can do a mirror image. How far do I go down? 1, 2, 3, 4, 5. So we go left 8, I'm going to go up 5. Find that other point. So there's the points I would use to plot. So we do have to be careful about the stretching. Well, how does that actually affect our table values? So there we go. The domain and range here are all real numbers. So again, we're going left and right forever and up and down forever. I'm going to have you try this one. It's a square root, so make sure you look at what the parent function may be. Also make sure that you write down what the domain and range are. It's going to be a little more difficult here. Maybe look to see if you can get the domain and range for that graph. And so that's graphing the square root and cube roots. Some of these we can do with a calculator, and we'll do these with the calculator tomorrow in class to start it off. I'm not going to do it on the video. We can pull it up on the graphing calculator, make sure you know how to punch that in quickly, and use the table to help you plot the points. So we'll have a call it a good night. Make sure you complete the homework problem. We'll see you tomorrow.